So let's recap on what a computer is. When we think of a computer, we think of this magical device that we can put instructions in or different inputs that we give it, and then it does something with that. But when it comes down to it, all a computer is doing is a very singular, simple task, one at a single time. And so, kind of looking at that, we realize that, if we write a program or if we tap a button on a screen, it's just performing a bunch of discrete tasks. And so, how do we make the computer go faster if it's only performing one thing at a time? Well, it turns out there's a really cool technique that we can use. Let's say you own a coffee shop and you want to make coffees as fast as possible. You might think that the best way to do that is just to make coffees one after another and try and do that really fast. But actually, it's much better to split it up and do something that we call pipelining. There are 3 steps to making a latte. First, you got to grind the beans. Then, you have to pull the shot. And then, you got to froth the milk. Now, if we did all of these one after another, we would make a bunch of lattes, but we wouldn't do it in the fastest way possible, because while we're grinding the coffee, the espresso machine is not pulling shots. And so we're losing time right there. We're losing cycle time. And so what we can do instead is, while we're grinding, we can be pulling a shot. And then while we're pulling a shot, we can be frothing. And what we start to do is we kind of stack these processes on top of each other. And this allows us to be a lot more efficient with the resources we have. When our first customer walks into the shop, we start by grinding the coffee. And then the next customer walks in, they order another latte. Well, we can't double grind the coffee, but while we're pulling the shot, we can be grinding the coffee for the next customer. And let's say that another customer walks in. Well, we can't be double grinding again, and we can't be double pulling the shot. But what we can do is, while we're frothing the milk for the first customer, and while we're pulling the shot for the second customer, we can be grinding the coffee for that third customer. And this kind of cascades into a layered process that we can use, and that is called pipelining. Now, I'll note that we still have exactly one coffee shop and exactly one person making that coffee. The difference is we're using our resources more efficiently. So now getting into more of the nitty-gritty. We have this coffee shop example, but how can we apply that to more of a computer architecture? Well, let's say that each customer is a task. It's an instruction that the computer needs to compute. And so as we're going through, we can see that there's multiple steps that a single instruction takes as it goes through the cycle of being calculated. And so we can kind of look at each task, and then we can split up all the different parts of a computer. And we eventually get to the point where we have this optimized, pipelined processor that can split all these things up and perform multiple things at once. And I want to go back to that last point I made in the example. This is not a parallel computer. Instead, it's just using all of the resources it has. That's the ALU, the fetching capabilities, the write-back capabilities. It's using all of those at the same time so that we're not, having idle hardware. And so when you look at pipelining as a whole, you realize that all we're doing is just saying, hey, I want to use the resources I have in a more efficient manner. And it turns out to be super powerful.